Hello everyone, welcome to semester 2. We are going to begin with chapter 7 and the first lesson would be 7.1 graphing exponential functions. A follow-up worksheet will be sent through WeChat, so you need to go through the slides, the PowerPoint that I'm sending, the recorded PowerPoint slide. If you do not understand, go through time and again until you understand the concept, and all follow-up work will be uploaded online. To begin with, we have graphed and polynomial functions in semester 1, and if you remember, there are two to three ways where you can remember the end behavior of the graph. If you have a leading coefficient, positive leading coefficient and even power, both the ends of the curve will be facing upward, and if you have a negative leading coefficient and positive even power or even power, both the ends of the curve will be facing downward. And if you have an odd power and positive in one, you have right upward and left down. Similarly, if you have negative leading coefficient, right up and left down. Left up, right down. In today's class, we are going to talk about graph of exponential functions and graph of exponential decay functions. To begin with, these are the list of vocabularies. I'm not going to repeat go through one by one because we don't have time, because I'm pretty sure that I cannot upload a long video online. So there's a link that I have sent it here. I want you to click on this link and write down the definitions of each of these functions. So this will be the first homework assignment for you. So if you look at this one, this is how a page would look like. You have an exponential function, click here, you have the definition for this one and copy this. So that will be your first assignment for this semester. Okay, now to begin with, a parent function of exponential growth function would be denoted by f of x equal to b to the power of x. Here x is positive, so b has to be greater than 1, and the type of graph would of this function will be always continuous and it will always be increasing. You have a positive, the domain would always be the all real numbers and range will be all positive real numbers. No matter what value of x you put, -5, -6, -100, the value would always, it will come closer to 0, but it will always be above 0. And you have the asymptotes will be the x-axis and 0.1 will be the intercepts. Now you are asked to graph this function and state domain and range. In order to graph these functions, you have to select the table values, plug in the values. You might start with -2 to +2, as I have already said, 5 possible values, and then you can get a good range of graph, and then you can predict the domain and range. Even if you don't graph it, as if you look at this function, this is similar to the earlier function that we looked here, the parent function. So this one will always have domain all real numbers and all positive real numbers. The range will be all positive real numbers. Now if you graph this, I have already done this one. So if you graph this function, this is the table value that you will get it. So if you look at this one, as the value of the domain increases, the range is growing exponentially, 1, 4, 16, and it goes on exponentially. Now this is the graph of the functions, and the domain would be always the real numbers and range is always the positive number. No matter what value of x you put, whether you put -32, -42, you still get values, positive real values. Okay, so that's why. Okay, this is a follow-up activity for you. Now tell me what will be the option for this one, A, B, C, D. Probably you must have guessed it. Here's the answer, C. Okay, what will be the domain? Domain would be all the real numbers. And what will be the range? Range will be all positive real numbers. Okay, positive real number. Please mind it positive. There is no negative value. You cannot have values here down for this function. Okay, next concept that we are talking about is transformation of exponential functions. We have done a lot of transformation of polynomial functions and quadratic functions in semester 1. Basically, it's given by two factors, h and k. H represents the horizontal translations and k represents the vertical translations. If h is positive, you move to right, okay, and if h is negative, you move to left. Similarly, if k is positive, you move up, and k is negative, you move down. This A talks about the orientation and shape. Okay, orientation means whether it's reflected in x-axis or reflected in y-axis, x-axis, above the x-axis or below the x-axis, and the value of the k, if it is greater than 1, if the modulus value of k is more than 1, the graph is vertically stretched, and if A lies in between 0 and 1, the graph is vertically compressed. Okay, vertically compressed. So if A is negative, it's reflected in x-axis. Take this as put it on your notebook. Take down the notes. Okay, now if you look at this one, there is a function here, the main function here, f of x equal. So this is similar to this one. So if you look at this one, there is no h, but there is a k here. So it's -2. What does it mean? Is it horizontal or vertical? So it's a vertical shift, right? It's a vertical shift. Since it's, if you follow, it's plus here, so its value is k, so it is vertically down by 2 units. So the equation represents a translation of graph down by 2 units. It's going down by 2 units. In order to graph these functions, you need to plot the value of x and y, and then these are the values that we have it. You can take your time, use a calculator, and then get the value. And if you plot the graph, this is how the graph would look like. Now if you look at this one, 2 will be the asymptote here. Okay, 2 will be the asymptotes here. If let's go back here, see this value, when you hit -3, it's coming closer and closer to -2, coming -2. If you take -4, still it will be, but it will never cross 2. Okay, you can try with -4, -5 and see. So the domain would be all real numbers and range would be y greater than or equal to -2. Okay, it will always be greater than -2. Now if you look at this one, there is no k here. If you look at this function, the parent function here, there is no k here, which means this is a horizontal shift. Okay, this is not a vertical shift, this is a horizontal shift. So in the horizontal shift, it's similar to this function minus, which means 1 is a positive value. So if it's a positive, it moves to the right by 1 units. Okay, similarly, you can take the table values, plot the graph and get the values. For this one, the domain would be all real numbers. Since you don't have k determines the vertical shift up and down, which is the y value. So in this case, the domain, the range will be all positive real numbers, okay, above 0. So this is how the graph would look like. Okay, now if you look at this function, tell me what's an option, what's the best option here? It's vertically shifted by 4 units down. So the answer is C. Okay, that's it for today. We are going to talk more on this in the next class.